Algebra 1, Unit 2, Understanding Functions, Module 3, Functions and Models, and Lesson 3.2, Understanding Relations and Functions. This is the one we did in class. The only correction that you'll have is this right here should be 0.2 inches per hour. So why don't you go ahead and pause the video and try that. All right, guys. So the answer for this is right here. Take a look, and if you have a question, we could talk about it in class. Okie dokie. All right. Oh my, I forgot to get this ready, so let me make a copy of this. Paste. Let me clear this. There you go. So today the essential question is before that we're understanding relation and function. So we have to have a definition, right? So we're going to start with relations. The very first thing we have over here, this one here is the definition. What is a relation? Relation is basically any set of ordered pair xy where x is the input value and y is the output value, right? Now here, there's no rules about the relationship between the x and the y. So when you have any ordered pair, basically, it's called a relation. And then furthermore, the domain is all possible values of the input relations, right? As you can see right here. But input is the x value. So what we can think of is that x is the input value, and we have a very fancy name for that is that's the domain. And here the range is all possible values of the output values, output value of the relations. That right there is called the range, right? So basically, a relations is if you have any pair, ordered pair, x, y, because x goes first and y goes second, right? Hence the ordered pair. So for example, given the relationship between these two over here, what's my domain and the range? Well, what's my domain? X values, right? So it is 1, 2, 3, and a 4. So this 1, 2, 3, and a 4 are the X values. Yeah? Then they're called the domain. And the range in this case are the Y values, right? Which is what? 4, 8, 12, and 16. So that gives you 4, 8, 12, and 16 right there. Okie dokie. All right, guys. Here is the example A. So here, it's important that you understand this is a relation, right? They're claiming that this is a relation right there, okay? And the input x, or the age of the boys, and output y, which is the corresponding height in inches. And there are three major ways to display that aside from a set notation, right? The one is a table, the other one is a graph, the other one is completing a mapping diagram, right? When I'm writing it, usually it looks like an oval shape like this, right? All right, guys, why don't you go ahead and try this and see if you can get this, and then tell me what the domain and the range of each this relation that's given to us is. Okay, please pause the video. Okay, here we go. I'm gonna assume that you worked it out. So, oops, wrong one. Here we go. This is what I did in period 4. All right. In a table, you just list all the x values here and the corresponding y values here. The keyword is corresponding y value because they are ordered pair, right? 7 and 41 are linked together. They have to be together, right? And then in the mapping diagram, you just put an arrow. So this is a start. So domain, the input, that's a starting value, isn't it? So we got a starting value over here to this, and then so on and so forth. It just turns out that number 10 goes to 52 and 53. Okie dokie. And then putting in here, we got 7 and 41. 7's right there. 41, you know, it's a slightly above 40, so you gotta do your best, right? So this is a table, this is a graph, and that's a mapping diagram. There are three different representation of the same thing, right? And depending on the situation, one is better than the other. But in this particular case, you know, this is fine. For me personally, it's easy to write this one, and just to see listing the numbers, right? But so this gives you how the numbers sort of like go. So you could clearly see over here that number 10 goes to two different values, and that might be hard to see over here. And then over here, you could clearly see that for 10 has two different y values, right? So they have all strengths and weaknesses. So depending on what we need, we choose the appropriate way to display the information. Okay, guys, and domain and the range over here, guys. We good? All right. I don't know if you noticed this. I listed the 10 only once. Okay, generally speaking, we do not write it twice. Even if it appears more than once, we just write once. Okay? All right. Okay, so let me copy, paste. There you go. And let me clear this one here. Okay. So now we're going to talk about functions right here, guys. So before we do that, we need to sort of define what it is, right? So first bullet point is a definition. Function is a correspondence between two sets, D and R, that assigns, oops, that should be a comma right here, okay? D and R, that assigns each member of D exactly one member of R. So there's a very, very specific relationship between the input and the output. In that, we have another way of expressing the same thing, which is a function is a special type of relation where there's only for each one input, for each input, there's exactly only one output, right? Well, another way to say it is this right here, is that for every input value, there's a unique output. Unique means there's only one. Okay? So for example, what we have here is a y equal to x squared. When the input value is 3, 3 squared has to be equal to 9. It can't be anything else if it is a function. The way I learned it as a kid, when I was a little person, learning math, and I still remember this. The way I was taught about the equation of the function was, it's like, hey, it's like having a little machine over here, right? What this does is whatever the input is, it just adds 3. It comes out this way. We're going to list that as y, and whatever we put in here is an x. So if I decide to put in -3, the machine adds 3 to that. And -3 plus 3 gives you what? 0. What if I put in 2? 2 plus 3 is 5. What if I decide to put 1997? Plus 3 gives you 2000, right? And the way we'd write that as an equation would be y is equal to the input x plus 3, or we say f of x. When you say f of x, it's a machine called f, function f, where the input is x. And then what do we do to the input? We simply add 3. So the equation, or in this case a function, is a basically set of direction. You're telling a machine what to do. When there's an input, in this very simple machine that we just created, just add 3, and so on and so forth. All right, guys? Okay, so here's example number 1. Okay, why don't you go ahead and try to do what you can using these right here, guys. Okay, I'm going to pause the video. Go right ahead. Okay, here it goes. So I did one for each class, and here's what I did over here. Example A, the domain is just x values, right? 40, 50, 40, 45, and 50 right there. And then the range is 2, 3, and 4. We generally write them once, even if they appear twice. And then we generally put them from smallest to largest. For example, B, my domain will be 10, 16, 17, 20 on the left-hand side. That would be the G as in gallon. Distance in miles, I decided to use the M, will be 150, 240, 300. Notice that there are two 240s, right? But when we list them as a range or domain, we only write them once. And then how do we use them? Well, I just said, hey, that's from 40 to 50. So if that's 40, and let's use 5, to be technical, you put a little break here, right? Right. And then I said this is from 1 through 5, and I just matched them, right? And then, so you, for example, when you do this one, right? So my x is 40, and my output y value is 2, right? And then, or visually, you could say 40 goes to 2, 45 goes to 3, 50 goes to 4. And I did the same thing right here, guys. The important thing is that I noticed that this goes from 10 to 20, so the furthest point out is 20, and then I just going backwards like this. Half of that, between that is 15, and so on and so forth. Notice that this is 300, I divided into like 3 100s, and so estimated the values there. The thing that's special about the example B is that 17 and 16 go to the same thing. The question is that a function? And some will say no, but it is a function because the definition of the function is what? For each input, there's one output. Does 17 have one output? Yes. Does 16 have one output? Yes, it does. Function never said that you can't have the same output, right? Exactly. All right, guys. And so they're both function and relations, right? So function is a special kind of relation. So they're automatically both relations, and they are both function as well. Okie dokie. All right. So here is your turn. Let's see if you could do this. The numbers are, that's missing in notes, is 4, 6, 7, 9 over here, 50, 85, 85, and 100. Okie dokie. Pause the video, please. Okay, we just returned, and here are the answers. Okay, guys, if you have questions, we'll talk about it in class. I'll see you again later, okay? Have a good night.